As one of the 7 natural wonders of the world, the Grand Canyon features some of the most distinctive ecological attributes on Earth. Each layer of rock represents a different chapter in the Earth's history. From the darker, more Precambrian rocks at the bottom, contrasting with the lighter sedimentary layers towards the top, this evidence allows us to visualize how the Earth's crust might have shifted and changed over time due to rain, erosion, freeze, and many other geological processes. It's important to recognize the desert-like environment of the Grand Canyon. Aside from its renowned geology, the ecosystem is shaped by dramatic changes in elevation, creating harsh contrasts where life has had to adapt to thrive in various extremes. The south rim is located about 7,000 feet above sea level. Because of this, having snow or hail during winter, even into early spring, is not uncommon. In this area, high temperatures can range from the 70s to 80s to the low 30s in the summer. The north rim is generally higher in elevation and experiences cooler highs during the summer. Though the lower into the canyon you go, temperatures can rise to over 100 degrees in the summertime. Due to the varying elevation, different areas of the canyon can experience different weather at the same time. Seasons in the Grand Canyon can shift dramatically. In the late spring and early summer, you can expect the driest times of the year. The sun is hot, and in turn, the water sources are more scarce. Though by late summer, the warm air produces powerful thunderstorms that trigger flash floods, which corrode and reshape the landscape in little ways over time. During the winter into early spring, snow falls over the canyon. Since the north rim is at a higher elevation, it gets the heaviest snowfalls.
Most of the soil is shallow, dry, and easily eroded. Biological soil crusts cover a large portion of inner canyon soil and play an important role in reducing soil erosion, so desert plants have a stable enough environment to survive.
The Grand Canyon is home to a numerous amount of native species throughout all of the differing habitats.
Rock squirrels live in the pine forests and woodlands. Their speckled gray and brown coats blend seamlessly with the terrain.
In the dry slopes of the pinyon juniper woodlands, drought-tolerant plants like Utah juniper, pinyon pine, and black sagebrush not only endure the harsh conditions, but also support a wide range of organisms in various ways.
From the canyon floor to the mountain rims, the Grand Canyon has many diverse habitats. At its lowest and narrowest zones are the riparian ecosystems. They cover the smallest area, but many organisms are drawn to the abundant water and lush vegetation. Just above the river is the desert scrub ecosystem, the hottest and driest ecosystem. It is home to most of the reptiles in the Grand Canyon and plants that adapted to scarce water supply. In this ecosystem, competition for water and nutrients can be particularly intense. Plants like the brown-spined prickly pear, sagebrush, and green ephedra compete for the moisture that can be scarcely available.
Climbing higher, you'll find the pinyon juniper woodlands. This habitat gets half as much rain as the desert scrubs due to the higher elevation. Moisture in the soil is not as easily retained since it's less sheltered and rockier. The black sagebrush is a foundation species. Being a primary source of food for mammals, it is also known for stabilizing the soil and providing shelter for many organisms. At times, plants and animals manage to divide up their resources to avoid direct competition. Utah junipers have deep roots that can access water where shallow-rooted scrubs such as the black sagebrush cannot. This is an example of how some species can carve out their own ecological niche. Utah junipers are also known to absorb nutrients from soil in a process called nutrient cycling, which are then passed on to herbivores and predators. When these animals die, their bodies decompose and return those nutrients to the soil to nourish new plants. The arid landscape forces many plants to rely on an alliance with fungi beneath the soil. Through their roots, plants provide carbon to these fungi. In return, it boosts nutrient availability in the soil and increases plants' drought tolerance. The second highest elevation point is called the ponderosa pine forest, which gets an average of 5 feet of snow each year. It's most known for the ponderosa pine tree, which many organisms rely on for pine cones, sap, and branches for shelter. To avoid being seen, the rock squirrel is an expert at camouflaging itself seamlessly into the rocky landscape in case of predators. Commensalism is exhibited in the way rock squirrels often use thick vegetation, such as a thick leaf beard tongue, for shelter from predators without harming the plant much at all. With thunderstorms being a normal occurrence in the summer heat, the tall trees are common targets of lightning. This causes forest fires, which are a natural part of the ecosystem. A lot of the fires are prescribed fire treatments to prevent or contain natural occurring ones. Lastly, the mixed conifer forest sits atop at an elevation of 8,000 to 9,000 feet. It receives the most rain and snowfall and is the most lush ecosystem in comparison. The most common trees are deciduous and evergreen types, providing dense canopies to shelter small mammals. Deer and elk are known to roam here and use its forest for protection during colder months. Larger herbivores like elk are important key factors. They graze selectively, feeding on certain species like the black sagebrush, which can limit the plant's ability to grow and reproduce. Over time, the selective feeding habit can lead to changes in the plant community and pave ways for other species to dominate in the black sagebrush's absence. Predators such as red-tailed hawks and mountain lions control populations of herbivores like mule deer, rabbits, and elk, halting the issue of overgrazing on vegetation and balancing the food web overall as important keystone species. These relationships between species in the Grand Canyon all share roles in shaping and balancing the overall ecosystem.
Even though this area is open to the public to enjoy, humans have had a negative impact on the area. Introducing non-native plants, such as cheatgrass, and animals like the brown trout, have disrupted the balance in the ecosystems, forcing some organisms to dwindle in population. These non-native species outcompete native organisms for resources like food and living space. Air pollution from surrounding industrial areas drift into the canyon, which affect the quality of air these organisms live in. The canyon is a popular spot to visit, but many people aren't informed enough to treat it with respect. Construction of the Glen Canyon Dam irreversibly changed the riparian ecosystem below it. Construction interrupted the flow of the river, leading to different sediment patterns, water temperature, and life cycles of native species. Efforts to protect and restore the canyon have gained momentum. Laws have been passed and targeted programs have been implemented to conserve natural beauty at the park. Pest management teams are actively working to reduce populations of invasive species. Park workers are instructed to inform visitors what not to do in certain areas. No-fly zones have been established to preserve the natural quiet, and to avoid catastrophic wildfires, rangers use selective burning and forest thinning. Due to pressures over climate change, climate models have predicted warmer temperatures and shifts in the rain patterns, which could alter the already changing availability of water. The threat of fires or other extreme weather events could disrupt the balance of these habitats, which can make way for invasive species that are more tolerant to these circumstances. Even so, the Grand Canyon's ecosystems and unique biodiversity have withstood the test of time, and new challenges may push these systems in new directions, but with collective effort, we can hopefully conserve the beauty of this natural wonder.